What is going on, guys? Welcome to another amazing chemistry tutorial, and in this tutorial I'm going to be talking about covalent bonds. Sounds exciting, right? So covalent bonds are the other main type of chemical bonding aside from ionic bonds. And actually, unlike ionic bonds, no electrons are transferred between atoms. So the goal of all atoms, whether they're about to bond ionically or covalently, is basically they want to complete their valence energy level. They want to fill it up. That's when atoms are satisfied and happy and stable. So that's the goal of all atoms. However, a covalent bond is, instead of giving away or taking an electron like an ionic bond, they decide to share their electrons. Pretty weird, huh? So let me go ahead and draw a diagram. So say we have hydrogen right here. Now hydrogen, as you may know, it has one valence electron on the outermost energy level. So basically it has one valence electron. However, the outermost energy level can hold two electrons. So that's what all hydrogens are looking for, two electrons to satisfy it. So say it runs into another hydrogen. Now this hydrogen is going to be in the same boat. He's going to say, okay, I have my energy level right here, and I have one electron. Well, what's going to happen is basically this. Whenever hydrogen, I'll just name this one, hydrogen number 1, finds another hydrogen, it's going to ask it for its electron. It's going to say, hey dude, you see this electron over here? That's looking pretty good. You mind if I take it? Because then I can use that to fill me up. Well, this this hydrogen, hydrogen number 2, is not going to give up its electron, because if it does, then it's going to have no electrons and it's going to become even less stable. So that's just not going to happen. So what happens is the hydrogens bicker back and forth, saying who's going to take what, until they finally agree that, okay, you know what? Why don't we just share our electrons? So the final graph or diagram or example, whatever you want to call it, it basically ends up looking like this. You have two hydrogens, and instead of one having both of them, they decide to share their electrons just like that. And that kind of looks like something perverted. I'm not going to get into that right now, but this really is what ends up happening. So that way, whenever they share their electrons, the electrons are going to orbit around both the first and the second hydrogen, and that way both of the hydrogens think that they have their energy levels filled and they both are satisfied. Now this is pretty much the basics behind a covalent bond. Instead of transferring electrons from one place to another, you basically share the electrons instead. It's a much more nice theory once you think about it. So instead of drawing all these perverted looking diagrams, chemists actually came up with a better way to write this using something called the electron dot formula, or I call it the electron dot technique, but it's probably called the electron dot formula, so I'll just go ahead and try to stick with that. So instead of drawing the Bohr model that looks like a pair of boobs over and over again, valence electrons are represented with dots. So, oh, that's kind of embarrassing. So say you would have a hydrogen, you would just put one dot right there. And say you would have another hydrogen, you would put another dot right there. So basically one dot means one valence electron. So if you would combine this hydrogen with this hydrogen, you would end up with something looking like this. Hydrogen, hydrogen, and the two dots are shared between them. And we call that the electron dot technique, where any of the dots that are shared, we just assume that that is a covalent bond, because, you know, it's a whole lot easier than drawing that huge Bohr model. However, chemists came up with an even easier way to represent this, and that's with, it's pretty much the same thing, but it's a modified version where instead of two dots representing a covalent bond, you pretty much use a dash instead. So the basic is pretty much like this. You have two hydrogens, and instead of drawing two dots, you have a dash. So that's what most chemists use, although if you use two dots like this, they're probably still going to understand what you mean, but more commonly you use a dash instead of two dots. Make sense? And I think this is called, whenever you use the dash, it's called the Lewis dot formula instead of the electron dot formula, but I'm not positive on that, so don't quote me on that. So aside from all that, let me go ahead and give you one more example, because hydrogen is really simple to see, but sometimes you need something a little more complex to really get the point across. So say you have something like chlorine. Now chlorine has 7 valence electrons. Now you draw those like this: 1, 2, 3, 4, 5, 6, 7. Now if it wants to bond with another chlorine, you would draw the other chlorine. So 1, 2, 3, 4, 5, 6, 7. So each of these chlorine atoms has 7 valence electrons, and that's how you would draw it. However, if you wanted to draw it in a proper Lewis dot formula, you need to draw it like this: chlorine bonded with chlorine, and then you start drawing the valence electrons: 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, and then you would draw the electrons that they share. One for this one, and the other for this one. So now you can see each of these chlorine atoms has a full valence energy level. They're both happy. They're both bonded into this, what's it called, covalent bond. However, more typically people use, instead of those two dots, they typically use, if I can undo those, I keep writing crap all over, they typically use a dash instead. So this is actually a whole lot easier than drawing that Bohr model with a chlorine, then energy levels 2, dot 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 dot. This is a whole lot easier, this Lewis dot formula. So that's what I'm going to be using from now on. So that's basically it. That's basics behind the covalent bond and the electron dot formula and the Lewis dot formula. So hopefully you guys' brains are about to explode. And once you understand this, you're ready to move on to my next tutorial. But for now, thank you guys for watching. Don't forget to subscribe, and I will see you guys next time.